In this video, we're going to be talking about curvature, and in particular, we're going to be talking about curvature when a function is of the form y equals f of x. And the formula that we'll be using is the curvature k of x is equal to the absolute value of y double prime divided by 1 plus y prime squared whole to the power 3 over 2. So we have this problem here that tells us y is equal to 5 over x. We want to A, find the point on the curve at which the curvature is a maximum, assume x is greater than 0, and B, find the limit of the curvature as k as x goes to infinity. Okay, so if y is equal to 5 over x, then y prime is equal to minus 5 over x squared, and y double prime is equal to 10 over x cubed. Then the curvature k of x is the absolute value of 10 over x cubed divided by 1 plus minus 5 over x squared to the power 3 over 2. And since we were told in the problem that x is strictly larger than 0, I can go ahead and drop the absolute value on top and say this is 10 over x cubed and divide the whole thing by, let's see, in the next step I'm going to find a common denominator. Let me go ahead and just write here 25 over x to the power 4 to the power 3 over 2. So as I said, I want to find the common denominator and simplify this even further. So here I'm going to have x to the power 4 plus 25 over x to the power 4 whole to the power 3 over 2. And we know that that power gets applied to both parts of the fraction, so this is 10 over x cubed divided by, we have x to the power 4 plus 25 whole to the power 3 over 2 divided by x to the power 4, and when I raise that to the power 3 over 2, that's just x to the power 6. So this becomes 10 over x cubed times x to the power 6 over x squared, x to the power 4 plus 25 whole to the power 3 over 2, and that is 10x cubed over x to the power 4 plus 25 whole to the power 3 over 2. So that's our k of x. And because the problem told us that we want to maximize k of x, we know that that means we need to take the derivative and set it equal to 0. So dk dx is equal to x to the power 4 plus 25 whole to the power 3 over 2 times 30x squared minus 10x cubed times 3 over 2 times x to the power 4 plus 25 to the power 1/2 times 4x cubed. And all of that is over x to the power 4 plus 25 to the power 3 over 2 and then squared, so that's just to the power 3. So let's simplify as much as we can. It looks like I can factor out 30x squared times x to the power 4 plus 25 whole to the power 1/2. So that leaves me inside with just one copy of x to the power 4 plus 25 from the first place, and then from the second one I'm going to have the coefficient will be 4 divided by 2, so minus 2, and then I have 4 copies of x. So minus 2x to the power 4, that whole thing over x to the power 4 plus 25 cubed And lastly, I just want to cancel that x to the power 4 plus 25 term. So I'm going to say 30x squared times, inside parentheses here I have 25 minus x to the power 4, and all of that over x to the power 4 plus 25, and it's going to be to the power 5 over 2 now, because I'm taking out 1/2 power. And that's my k prime of x. So I want to know where k prime of x is equal to 0. And since it is a fraction, we know that k prime of x equals 0. That just means that the top of the fraction is equal to 0. So 30x squared times 25 minus x to the power 4 is equal to 0. So that would mean either 30x squared is 0 or 25 minus x to the power 4 is 0. But since x is greater than 0, we know that 30x squared is greater than 0. So it has to be 25 minus x to the power 4 equal to 0. So that's x to the power 4 equal to 25. So the two real roots are going to be x equals minus square root of 5 and x equals square root of 5. But again, we're looking for the maximum when x is greater than 0. So we're going to take x equals square root of 5 to be our x value. And we want to know the y value because we're looking for the ordered pair. So since our function was 5 over x, f of square root of 5 is 5 over square root of 5, and that's square root of 5. So the point of maximum curvature is going to be square root of 5, comma, square root of 5. So that answers part A. Part B has asked us to find the limit of the curvature as k goes to infinity. So part B, x goes to infinity of the curvature k of x. That should be the limit as x goes to infinity. And the curvature of x we said was 10x cubed over x to the power 4 plus 25 whole to the power 3 over 2. Now we could analyze this using L'Hopital's rule, but if we just take a quick look, it looks like the power of x on the bottom should be 6, whereas the power of x on the top is 3. So I'm just going to say this is 0 because the bottom grows faster than the top. Oops. That out of the way. Than the top. And that answers part B.